Now let's talk about how DICOM works. There are two main components of DICOM, and they are the DICOM file format and the DICOM Network Protocol. These two elements work together so that the images are in a standard format and the exchange of images is also standardized. Finally, DICOM works because everybody uses it. If a device is not DICOM compliant, nobody's going to buy it today. DICOM file format. All medical images are saved in DICOM format. Medical imaging equipment creates DICOM files. Doctors use DICOM viewers, which are computer software applications that can display DICOM images to diagnose the findings in the images. DICOM files contain more than just the image. Every DICOM file holds patient information such as patient's name, ID, sex, date of birth. Each DICOM file holds important acquisition data such as the type of equipment used and what settings were on the modality. So that data is all embedded inside of the image. The DICOM Network Protocol. All medical imaging applications that are connected to the hospital network use the DICOM protocol to exchange information, mainly DICOM images, but also patient and procedure information. The DICOM Network Protocol is used to search for imaging studies in the archive and retrieve imaging studies to the workstation in order to display it. There are also more advanced network commands that are used to schedule procedures, report statuses, and share the workload between doctors and imaging devices. The main benefits of the DICOM standard are this. It has excellent image quality. DICOM supports all 65,536 shades of gray. It is universally adopted medical imaging standard. All imaging devices use DICOM, making them easier to connect to the network. It has full support for numerous image acquisition parameters and different data types. It includes the patient and device information, not just the image data. It has complete encoding of medical data. DICOM devices use more than 2,000 attributes to convey precise medical information. Clarity in describing digital imaging devices and their functionality. Working with devices that are DICOM interfaces is a predictable process. That really means that an ultrasound scanner always behaves like an ultrasound scanner. As soon as you look at the DICOM information, you know you're dealing with an ultrasound scanner or a CT machine or an MRI machine. So, there's reality and there's DICOM. And DICOM converts real-world data into DICOM objects. DICOM objects are named after the real-world data counterparts. So a DICOM object that contained all the information about the patient would be called the Patient Information Object Definition, or Patient IOD for short. The patient IOD will have data such as the patient's name, identification number, date of birth, weight, etc., stuff like that. And there are many IODs. There are IODs for every modality type such as CR image IOD, CT image IOD, NucMed image IOD. There are information object definitions for many other things such as the contrast IOD or the display shutter IOD or the device IOD. So chunks of data get grouped together and turned into information object definitions. So here's a better representation from the book. You have this patient in the real world, and he's a patient, and I don't know why he has this brown stain all over his gown, but he obviously has some sort of shoulder injury. So in DICOM, he is John Smith. His medical ID number is 123456. His date of birth is 1968, November 8th. He weighs 75.5 kilograms, and his sex is male. So all that information about him from the real world is translated into this data, and it becomes the patient information object definition. Now, objects are acted upon by DICOM services. DICOM services perform functions like move, find, and store DICOM objects. When a DICOM service is paired with a DICOM object, this is called a service object pair, or SOP. So if the image, the object, is a CT image, and that image is going to move from one place to another, the service is move. And so you end up with a SOP class of CT image move. And so you can see it's a combination of the object CT plus move results in CT image move. DICOM connections. DICOM contains protocols for how DICOM devices talk to each other. When you meet someone at a new meeting, there's a protocol. You say hello and you shake hands, and at the end of the meeting, you shake hands again. We all know that as a common protocol for when humans interact. We always do those things. Well, machines have protocols for how they interact, and those are the DICOM standards. Imaging devices and systems have similar protocols set forth by the DICOM standard. There's a standard greeting, an exchange of basic information, and even something called a DICOM handshake performed by the two imaging devices. We will go much deeper into this in another class, but for today, you just need to know that there's a detailed protocol in DICOM for the way two DICOM devices connect and talk to each other. So let's run that whole thing back. Medical imaging devices create DICOM files. DICOM files contain the image data, information about the patient, and other information about the image. It's not just the picture. It's what makes up the picture plus the data around that that explains what the patient is, what machine did it, all sorts of things like that. DICOM also contains networking protocols. It's not just a file format. It also is a network protocol. DICOM identifies something by a collection of its attributes, and those are called Information Object Definitions, or IODs. DICOM uses services to perform functions on the objects. A DICOM object plus a DICOM service equals a service object pair, or SOP. The DICOM networking protocol details a specific exact procedure for how DICOM devices connect to each other, including a DICOM handshake. Thank you for watching.